What do toys, car seats, and bottle caps have in common? They're all made with a manufacturing process called injection molding. This process works by injecting polymers, like plastic, into a pre-made mold. Injection molding allows parts to be produced quickly, efficiently, and at low costs. It all started in 1872, when John and Isaiah Hyatt patented a device for heating and injecting celluloid into molds with a plunger. This method was then used to produce items such as hair combs, buttons, and collar stays. Then, in 1909, Leo Hendrik Baekeland discovered phenoformaldehyde plastic, otherwise known as Bakelite, a thermosetting resin that was well suited to injection molding. Bakelite was found to be better suited for this process than celluloid. Bakelite has useful insulating properties that made it ideal for electrical applications. The 1930s marked the beginning of the use of thermoplastic materials, which are still in use today. Polystyrene, PVC, polyvinyl chloride, polyolefins, and Perspex, polymethyl methacrylate. This laid the foundation of plastics use in manufacturing as we know it today. Soon, more items would be made of plastic than ever before. 11 years later, World War II created a huge demand for cheap, mass-produced materials, and injection molding was the perfect solution. Then, in 1946, American inventor James Watson Hendry built the first extrusion screw injection machine, which gave much better control over injection speed and quality. This method overcame a major shortcoming of plunger-style machines, the uneven heating of the plastic material. Now, items could be created more quickly, efficiently, and cheaply than ever before. In 1956, another American, W.H. Willard, received a patent for a reciprocating screw plasticator. This reciprocating screw mechanism sat inside the plasticator machine and heated mixed plastic and allowed material to be moved to the right places. This method increased mixing efficiency by reducing cycle time. In the 1970s, James Watson Hendry developed the first gas-assisted injection molding process, which allowed for the production of more complex designs like those with hollow insides. It also allowed for greater precision while reducing surface blemishes, sink marks, and internal stresses. The improved design flexibility also meant better strength and finish, as well as reduced production time, cost, weight, and waste. In 1972, industrial robots and injection molding were combined for the first time. Using robots to perform secondary operations while the injection molding machine is working led to greater increased efficiency and output. At this time, mold design and process refinement were still expensive and required a lot of trial and error in the physical testing of new mold configurations and process settings. In 1978, mold flow simulation software was released. Engineers and designers were able to leverage the software to monitor injection pressure and temperature to optimize production, eliminating problems before they became expensive. 1985, Millicron introduces the first all-electric molding machine, which helped reduce energy costs and reduce the environmental concerns of hydraulically powered injection molding machines. By the end of the 1990s, Moldflow had released Moldflow Advisor, which opened up the technology for people who weren't dedicated plastic engineers. This software also made the process cheaper and easier to use and opened it up to an entire non-expert audience. When Autodesk acquired Moldflow in 2008, the process was paired with CAD and CAD translators. The software's focus shifted to a strong emphasis on ease of use and the user experience. With this booming popularity and the increased global demand for products, we began to see the integration of injection molding into other, more customizable applications. By the late 2000s, improved automation capabilities helped significantly cut down on labor and costs. And as the world became more eco-conscious, the industry saw a shift to using recycled, renewable, and reclaimed plastics. In 2010, Moldflow created the first cloud computing offering, providing computational power for optimization and design of experiments. Today, injection molding is used by engineers and designers to create almost everything you see around you, from tables and chairs to food containers and mop heads. As we progress, injection molding will tie further into the cloud, making the technology more accessible and collaborative. With injection molding cementing its capabilities into new integrations, the opportunities to create are endless. The future of manufacturing is clearly being molded for a new era of innovation.